Evolution of Bitcoin itself in terms of the size of the Bitcoin blockchain, going from nowhere to, as of a couple of days ago, almost 140 gigabytes, just in that blockchain alone. Think about the impact of blockchain. One of the problems we've had in security has been that someone has to trust someone. It has to be a trusted environment. The interesting thing about blockchain is, imagine combining the value of a public key infrastructure with an environment like blockchain, where trust isn't really part of the definition, and where you can have this trustless, non-reputable environment that pretty much forever allows us to trust all kinds of transactions, whether they're financial transactions, transactions that the military is doing, real estate transactions, wedding transactions, whatever the case may be. So blockchain, while sort of a hype thing right now, and do we or do we not do cryptocurrency, ultimately will be one of the foundational pieces of e-government, of smart cities, of everything we do in cybersecurity. And it has a lot of opportunities for us to solve problems we've never solved before. And there's another dimension to it, which is particularly interesting as well, which is the power of peer-to-peer networking. Think about just the hash rate that exists today in blockchain. You've got a 1 there with 16 zeros after it, 8 exahashes per second, just with the compute power of today's Bitcoin blockchain. And there are some problems with that. You know, for example, it is a risk, for example, if somebody controls too much of this compute power. But as we as professionals think about how would we do this, for example, in this country, or how would we do that in other places, there's opportunities for us to harness this kind of compute power and do it the right way. But there's more to this story. Sure, we need to solve problems like let's not make little mistakes, and we need to make sure that we test and validate these technologies properly. But ultimately, blockchain is in our future. But what could hurt us in blockchain? Well, something like this could hurt us. Quantum computing, okay? In theory, quantum computing could be used against the current blockchain approaches to break public key encryption. If you look inside a quantum computer, you've got this guy, Peter Shor, who created an algorithm that basically, given an integer n, would essentially find the prime numbers under that large number. So imagine a scenario where everything that we've encrypted for the last 30 years or so is suddenly visible. But again, why do we see that as a scarcity issue in security versus an abundance issue, where we embrace the ideas of quantum computing and say, given quantum computing, let's write post-quantum crypto. Let's develop cryptography that is going to solve for this problem. And let's think about how it would solve other problems. In artificial intelligence, this has been around for 30 years or so. I remember when I first heard about it, I was probably 20 years old, and that's a long time ago. And I just thought it was something out of science fiction. Why today are we starting to think about artificial intelligence as something valuable? Well, in the old days, costs of storage were a problem, limits of computing power. But as we saw earlier, there's been exponential increases in storage and compute power to where today we can say costs of storage are exponentially decreasing and costs of computing power is exponentially increasing. So we have the ability today to take advantage of situations in AI where we can collect lots and lots of data and never delete it. And that's the food that an AI uses to basically start thinking about things and learn from problems. Learn from things that it sees and says, maybe I made a mistake. Let me learn from that mistake, analyze it, and then do a better job the next time. We never had this opportunity before, and now we have it today. Now, up until now, AIs have been applied to problems like, Siri, how do I find my way to the Emirates Palace Hotel? Okay, but imagine a future, an abundant future in cybersecurity, where AIs are operating on your network and they're solving your cybersecurity problems. Cybersecurity is one of the most important problems we can apply an AI to. And I think it's one that we all should be working on today. So whether it's robotics, for example, for the medical industry, manufacturing, other environments, we think about self-driving cars and other types of self-driving vehicles, whether it's planes or drones or trucks, and the sensors involved, and having all these sensors learn what's happening. Or, as we're doing here in this country with smart cities, we need AI technology to both operate these environments, but more importantly, to take advantage of keeping cybersecurity environments away from this. It's not going to be what can I buy, what appliance can I put in my rack to help solve this problem, but it's going to be about using this new approach to technology to solve this and thinking about it abundantly. So when we think about how we roll all this together, the message that I want to leave you with really is about resilience. Because in the past, cybersecurity has been a very reactive function. It's been about, oh gee, some guy is now hacking me, some nation state is creating problems, some criminal groups have discovered that I have all my money in a certain place over here. And then we go around and look for how to solve that problem and react to it, and hope that that reaction can somehow keep up with the innovations of the criminal world or others. I would argue that the abundant future that we need to look towards and the exponential approaches that we need to look towards are those that we're already seeing in the marketplace, where we're seeing compute power be just continuing to grow. We're seeing AIs continuing to show promise. We're seeing quantum computing. We're seeing all of these advances all around us that are being used for our convenience and being used to make our lives better. We as cybersecurity people need to get together and start thinking way ahead and thinking, how can we research this? How can we work together? How can we invest in it? And how can we solve these problems together to create resilience in these environments that will be more and more dependent on one another going forward? That's what we're doing at DarkMatter, and that's what I would encourage all of you to do as you think about the way forward. Thank you very much for your time.